Welcome to class number 6 of Creation Science 104. We are covering what's on our seminar tape number 7, our frequently asked questions or question answer session. For those of you just joining us, you may want to watch the previous lessons or classes to get caught up. Okay, a question I frequently get asked is, what about the separation of church and state? By the way, I apologize for my voice. Still having trouble from talking too much 2 weeks ago in Pennsylvania. Strained something, I guess. Can creation or the Bible be discussed in public schools? Answer, absolutely yes. There are no laws against teaching creation science in public schools. There never has been. There are no laws against reading the Bible in a public school. There are court cases against teachers trying to proselytize students on state salary. I mean, if the state's paying you to teach, you can't try to convert the kid to be a Baptist or Buddhist or Catholic while you're being paid by the state. But there's actually no such thing as separation of church and state. That phrase is never mentioned in the Constitution anywhere. Thomas Jefferson wrote a letter to Pastor Danbury in Connecticut, Dayton, Connecticut, back in 1802. In the letter, Thomas Jefferson said, "The First Amendment has erected a wall of separation between church and state." And many people think that phrase is in the Constitution, and it's not. The Constitution simply says the government can make no laws regarding an established religion or establishing a religion. The government has hands off when it comes to religion, which is why the government has no authority to tax churches. They have no authority to require them to get building permits. They simply have no authority over the church, period. It's a separate sovereign, a different entity. However, most churches have fallen into the trap of becoming 501c3 corporations. And now the government does have the authority to tell them what to do, because the government establishes corporations. They allow them to exist. But a true church that is not incorporated or gets unincorporated, the government simply has no authority over them. 150 years ago, 200 years ago, congressmen and senators and representatives were scared stiff of preachers, because the preacher would get up in the pulpit and say, "Oh, Senator Jones did blah, blah, blah," and he'd just call his name and spill the beans on them. Well, churches were very involved in politics. Matter of fact, if it hadn't been for the churches, we never would have won the Revolutionary War. During the Revolution, King George's soldiers, in many instances, deliberately targeted churches to burn down, to try to arrest pastors, because they were the rabble-rousers. The book In Caesar's Grip, which we have in our bookstore over there, would be an awesome one to read if you want more on that. Jeff, have you got into that one yet? In Caesar's? Oh, you're going to love that one. By Peter Kershaw. It's an excellent book on that topic. Anyway, there's no such thing as separation of church and state. What it's supposed to be, the church, by the way, when Congress voted in the First Amendment, where they said Congress shall make no law establishing a religion, the same day they voted to give $100 or $500 or something to a Catholic missionary to help the Indians in St. Louis. Wallbuilders.com website is by David Barton. He speaks all over the world on the topic of what our founding fathers' philosophy was. And he said, the wall is a one-dimensional wall. It keeps the government from running the church, but it makes sure Christian principles will always stay in government. And we covered lots more on that earlier. So there's no such thing as separation of church and state. How can we see stars billions of light years away? I frequently get asked this question, matter of fact, every week. The atheists and scoffers, I do a debate this Monday night in California. I'll be doing a debate, and I'm sure it'll come up again, If the earth is only 6,000 years old, like the Bible teaches, the whole universe is only 6,000 years old, how do we see stars billions of light years away? Well, there's no question there's an awful lot of stars out there. The Bible says in Nehemiah chapter 9, "Thou, even thou, art Lord alone. Thou hast made the heaven of heavens, with all their host, the earth, and all things that are therein, the seas and all that is therein, and thou preservest them all, and the host of heaven worshipeth thee." There's no question the Bible teaches God made the stars, and there are a lot of them. But if stars evolve, like they tell us in school, star births should equal star deaths. Just logical. If the birth rate is less than the death rate in a population, what is going to eventually happen? Extinction. They're all going to be gone, right? If the birth rate is greater than the death rate, like it is right now, then the population grows. Well, Nova and supernova. A supernova is just a bigger nova. Supernova. Okay? Nova is when a star explodes, just blows up. And you can study for years about why stars blow up, and the theories at least behind what causes novas and supernovas. In Spanish, nova means won't go, will not move. Vamos is, va means go. Nova is no go. So when Chevy tried to sell the Chevy Nova in Mexico, it didn't go over very well. They had to change the name to something else. You want to buy a no-go? No, I don't want to buy a no-go. Stars have been observed to fall apart. They blow up. It's called a nova. Big ones are called supernova. It appears that one blows up about every 25 or 30 years on the average. Nobody's ever seen one star forming. Not one has ever been observed to form. Astronomers have observed about every 30 years a star dies and explodes into a supernova. If the universe is billions of years old, how come there are less than 300 supernova, dead stars? There should be several hundred million of them. ICR has a great article about that, September 1998, Institute for Creation Research. That's a good point. Let's suppose stars explode every 30 years on the average, and there are only 300 of them. 300 times 30, 9,000. 9,000 years. Max. Why, I thought the Earth was billions of years old. Why aren't there more dead stars out there? You won't hear the evolutionists or atheists talk about this much, but it is a very serious problem. There's no question there's a lot of stars. And I've had several skeptics tell me, oh yes, stars are forming in Crab Nebula. You can watch the dust out there and you see a bright spot in the dust. That's a star forming. Well, duh, if this was a court of law, and you said, Your Honor, I see a bright spot behind the dust, that proves a star is forming. No, Your Honor, that proves the dust is clearing. The star was there all along, right? And that's the only one they've got to hang their hat on. Okay, they think a star, they call it a star nursery. It's being born out there. Yeah, right. Maybe stars are being born. There's a problem, though. Dust does not accumulate. It takes an enormous amount of gravity to get it started coming in. But get a cloud of smoke. It'll never come together to make a particle. It dissipates. It falls apart. In order to get the dust to overcome the natural spreading out, called Brownian motion, in order to get them to overcome that, you have to have energy to squeeze it together. So you get all this energy to squeeze it together. Now you get a mass that has gravity, which starts attracting other things. But the energy required to squeeze it together is incredible. Actually, they say it would take the energy from 20 exploding stars to produce enough energy to make a brand new one. Had an atheist tell me in a debate one time, he said, well, if 20 stars explode near each other, it'll make a brand new star. I said, well, that's brilliant. You got to lose 20 to gain one. You ought to run for Congress and help those guys borrow their way out of debt. You're not going to get ahead if you lose 20 to gain one. I mean, figure it out. You don't need to be a rocket scientist to think about it. Genesis chapter 1 says, God said, let there be lights in the firmament of the heaven to divide the day from the night, and let them be for signs and seasons, and for days and years, and he made the stars also. The Bible's real clear. God made the stars on day 3, this would have been, or day 4. Day 4, he made the sun, moon, and stars. Day 3, he made the plants. So if he made the stars on day 4, after the earth. Now see, according to evolution, stars are made first and then the earth. According to the Bible, earth is made first and then the stars. Absolutely backwards. And guys like Hugh Ross and everybody's always trying to accommodate what they think is acceptable science with trying to make the Bible bend to fit their scientific theory. It's not going to work. Psalm 147, he counts the number of the stars. Interesting verse. That doesn't say he knows how many there are. He knows the number of each one. That is star number 2,572 million. He knows the number of each one. It also says he knows the number of the hairs of your head. That doesn't just mean he knows how many. It means he's a number of each one. See, there's number... No, that's pretty smart. It's been estimated there are enough stars in the sky right now that we've discovered that everybody on Earth can personally own 2 trillion of them. Plenty to go around. The Hubble telescope was directed to focus in on a dot. They thought they found a black spot in space, no stars, right above the Big Dipper. It's about the size of a grain of rice held at arm's length, a grain of sand held at arm's length, pretty tiny spot. The Hubble, because of the way it was positioned going around the Earth, it was able, even though it's going around the Earth, it was able at all times to focus on that spot continuously. You know, we can only see the stars a couple hours a night, then they're gone in the daylight. The Hubble was going around in such a position it could focus on that spot continually. After 10 days, they discovered there are more stars in that spot than they could count. These are ones they didn't know about before, plus the ones they already know about. Right. They say there are billions, if not trillions, of galaxies, and each galaxy contains trillions of stars. And each star contains how many atoms? Bunch, right? Stephen Hawking, who hates creationists, said, "Stars are so far away that they appear to us to be just pinpoints of light. We cannot see their size or shape. So how can we tell different types of stars apart? For the vast majority of stars, there's only one characteristic feature we can observe, the color of their light." When you get the biggest telescope in the world and look at the closest star, all you see is a dot. When we look at stars through a telescope, you just see nothing but a dot. Biggest telescope still sees just a dot. If you look at the sun through a telescope, you see flames leaping off, and you can see all sorts of features on the sun, the spicules on the surface, and it looks like oatmeal, boiling oatmeal. But you don't see that with a star. People say, oh, the sun is just a medium-sized star. Maybe it is, I don't know. But we don't even have a clue what the other stars really actually look like, other than their color. Now, when they study the star light coming in, they can tell certain things about it, what kind of metals are burning. If you burn a piece of copper in a hot flame, it'll burn green. Different metals burn different colors. So if you want fireworks for 4th of July and you want them to blow up and be red, you put in a certain metal. If you want them to be green or yellow, you can make different colors by grinding up metals, mixing them in with whatever's exploding. They look at these stars, and all you see is a dot. How do you tell the distance to something like that? How far away is it? Well, the way to tell the distance to an unknown object, some object you cannot touch, is to use trigonometry. If you get 2 observation points focusing in on a third dot, you can calculate the unknown distance if you know the distance between your 2 observation points and you know the angles with simple high school trig, sine, cosine, tangent. If you want to know the distance across a river, you stand one spot on the bank of the river, look at a tree, make a line, imaginary line, go down to another place and look at the same tree and make a triangle, measure the distance between your 2 observations and get the angles. You can calculate the distance across the river real accurately, depending how accurate your measurements are. Well, the problem is the Earth is only 8,000 miles in diameter. 8,000 miles is really nothing compared to star distance. So if I'm looking at a star here in Florida, somebody on the opposite side of the world in China is looking at a star. Actually, the opposite side's down south of the equator, 30 degrees, be the middle of the Indian Ocean. Opposite from Pensacola is in the ocean over here. The opposite through the northern hemisphere would be China, but opposite through the world is actually Indian Ocean. Who cares? Anyway, it's 8,000 miles across the Earth. If 2 people on opposite sides of the world are looking at the same star, they basically have 2 parallel lines, because 8,000 miles just doesn't count. What they've done to enlarge the base on the triangle, you look at the star in January, you wait 6 months, look at the star in June, and now you have a much bigger base on your triangle. You have a huge circle with Earth's orbit around the sun. This, of course, is assuming the heliocentric position, that the sun is in the center of the solar system. There are still a surprising number of people who are geocentrists who think the Earth is in the center. there is still a surprising argument out there, and there are some amazing points to be made for both sides. I don't have the answer. I currently am still in the heliocentric position. I think the sun is the center, and the earth goes around the sun. But I've heard some good arguments for the geocentric position. It'd be a good quiz question. Geocentric means earth center. Heliocentric means sun center. Helio means sun. 93 million miles from the earth to the sun, or from the sun to the earth. It'll be the same either way. It takes light 8 minutes to get that far. That's called 1 astronomical unit, abbreviated AU. The earth is 1 astronomical unit away from the sun. Mars is 1.5. Pluto is 39. So if you want to measure the distance from Pluto to the sun, instead of giving it to you in miles, which would be some giant number, I could give it to you in inches, it would be an even bigger number, and it wouldn't matter. Your brain couldn't work with that. But 39 astronomical units, that'll register. Mercury is 0.36, I believe. Venus is 0.7. Earth is 1. Mars is 1.5. Jupiter is 5. Saturn is 9. I used to know them all. I had my kids memorize them for science class. Who cares? Anyway, the distance from the sun to the earth is 8 light minutes. So what would be the diameter of our orbit around the sun? 16 light minutes. Right? So
does it change?
it changes insignificantly. And the diameter of the sun, even though the sun is massive, 880,000 miles, doesn't even count. It takes about 4 seconds for light to go from one side of the sun to the other at the speed of light. So that 4 seconds, the diameter of the sun, would be insignificant compared to the 8 minutes. Roughly 8 minutes for the light to get here. So if the sun blew up, disappeared. We would not know it for 8 minutes. Another phenomenon, as the sun is going down, the Earth's atmosphere acts like a lens and bends the light. We can actually see the sun after it's gone. Technically, it's already below the horizon, but you can still see it because it's being bent by the atmosphere. Plus, you have the 8 minutes that it took the light to get here. So the sun's long gone by the time you see it actually disappear. In reality, probably been gone for 15 minutes. I don't know what it is, but it's some number like that. And who cares? Okay. A year, yes, sir.
Is that true in the morning then also, that you would see the light before it actually
Yes.
rises up the horizon?
Right. Well, but then it'll probably cancel each other out. Let's assume the bending of the atmosphere gives you 8 minutes advance, but it took 8 minutes to get here.
Right.
So those would cancel each other out, but at night they would add to each other.
I was going back before the flood with the firmament of ice over the earth would cause a greater refraction and length of the day.
The firmament actually the firmament of ice, if it was ice, would not only lengthen the day for that reason. Carl Baugh's got a good book called The Panorama of Creation. He says the firmament would be fiber optic, where if a canopy of ice surrounded the earth, you shine the light on this side, the other side glows like a nightlight. So you cannot ever have total darkness.
Solid, or even as a liquid or a vapor, it would do that.
As a solid.
As a solid.
Ice as a solid would be fiber optic. He's got a whole list of things that super cold ice at, say, 400 below zero would do. He says it becomes fiber optic. I can't verify that. I can't prove it or disprove it. He says it becomes what's he call it? A photoamplifier. You can actually see more clearly. They can see the stars better than we can, like having a built-in telescope all the time over you. And he said it would actually resonate when the radio waves, stars produce radio waves, when they hit the ice canopy, it would cause it to vibrate, which changes then a radio wave to a sound wave, and you would hear the songs of the stars, the music of the stars. The Bible talks about that. The morning stars sang together. What's that talking about? Well, it sure preaches good. I can't prove any of it. Okay? Or is it angels, morning stars, sang together? Yeah, good point. The angels are often called the sons of God. Yeah, I don't know. I better think on that one before I make any comments. But the canopy then would act as not only to compress the air, making it less distortion. You know, as air gets hot, it expands. If you look down the highway on a hot day, you see little lines coming off. Okay, that's the air expanding, and it's distorting the light going through it. If the air today is about 100 to 200 miles thick, if you squeezed it down to 20 miles, still wouldn't matter as far as birds fly. They never fly up 20 miles anyway. You know, very few get up 5 miles. That's Mount Everest. But squeezing it down to 20 miles wouldn't affect anything except increasing air pressure and increasing clarity, being able to see more clearly, less distortion. Okay, a year, if you calculate it out, 365.2422 days in a year. For the Earth to go around the Sun and end up back in exactly the same spot is 365.2422. It actually goes beyond that, the fraction, but that's real close. If it was 365.25, it'd be real simple. Every 4 years, you add a day, leap year. But it's 0.2422. Well, that messes things up, okay? It works out, every 4 years you add a day, leap year, works out pretty good. But even that doesn't come out quite exactly right. So, every 100 years, like the year 2000, if it normally would be a leap year, which 2000 would have been, but it's also divisible by 100, then you don't add a day. That's why there was no February 29th in the year 2000. But there was in 96, and there will be in 2004. Now, Eddie over here, whose birthday is on February 29th, only has a birthday every 4 years, and he didn't get to have one. So he's still only 12. But in real human years and people years, he's, 52 or something like that, whatever it is, 54. So, and who cares? Take 365.2422 days in a year times 24 hours in a day times 60 times 60 seconds, and you can get the number of seconds in a year. But it works out to be 525,948 minutes in a year. A little over 500,000. If that little yellow circle represented Earth's orbit around the Sun, which is 16 light minutes across, and a year has 500,000 minutes, there's a big difference between 16 and 500,000. And if you were measuring this as a trigonometry triangle, you'd really create a problem here. Put two surveyors up on the roof of this building, 16 inches apart, with their telescopes, transits. Have them focus in on a dot 525,000 inches away. That's 8¼ miles. Would you agree that forms a pretty skinny triangle? Right? Now keep in mind, this illustration is to show you what 1 light year looks like using Earth's orbit around the Sun. Not the diameter of the Earth. Earth's orbit. Huge circle is nothing compared to 1 light year. See, a light year is a distance. It's not a time. And that confuses a lot of folks. A light year is not a time. It's a distance. How far does light travel in a year? About 6 trillion miles, roughly. Well, suppose it was traveling 6 trillion miles an hour. Then it goes a light year in 1 hour. Right? If I said it's 8 Hovind minutes from here to the store, that's how fast I can run. Okay, I can run there in 8 minutes. That's getting longer every year, by the way. But that's not a distance. Well, that's actually a distance. Hovind minute is a distance. If I speeded it up, it'd be quicker, right? So a light year is the distance light can travel in 525,948 minutes, or 1 year. Earth's orbit around the Sun is 16 light minutes. A year has 525,000 minutes. That makes an angle out at the point of 0.017 degrees. Get your protractor and try to mark off where 1 degree is. and try to mark off 17 thousandths of 1 degree. I'm talking a real skinny triangle. Even if we draw a circle around this whole property and tried to mark off 1.017 degrees, at the outer circumference of a huge circle around this property, it'd still be a real small amount.
Even just 1/10 of a degree.
A tenth of a degree is not much. 100th of a degree is even less. Okay. If you want to measure the distance to a star 100 light years away, simply add 2 zeros. Now it's 0.00017 degrees. And here we got guys like Hugh Ross saying we can measure the distance to stars, 17 billion light years away. I'm sorry, I just don't believe that. I'd have to see that. How on earth can you do that? And all of this is generously assuming you know where you were 6 months ago. Isn't it? I mean, if we got 2 surveyors on the roof 16 inches apart, they can see each other. They can see each other and measure the distance between their telescopes. How do you know exactly where you were 6 months ago?
Now, do you think they really try to use that to tell a distance, or do you
Yes.
think they really do try?
What they do, first you get the distance to a close object like the moon. That can probably be done just with 2 observation points on Earth. They keep refining that distance. Then they use a phenomenon called parallax. If you hold your thumb out, let's say your thumb is 3 feet from your eyeball, and your eyes are 4 inches apart from each other, center to center. If you hold your right eye open and look past your thumb to try it, look at the side, line your thumb up with the right side of the screen, and then switch to your left eye. You see it move back and forth, right? That's called parallax. Now, if you knew the distance between your eyeballs and the distance to your thumb, you could calculate a further distance out by using that parallax. So that we calculate the distance to the moon, then let's use the moon to calculate the distance to the sun. Then let's keep doing all this and cross-checking everything. And you get, most textbooks will say you get, with parallax trigonometry, you can measure distances of less than 100 light years. I think it's probably much less than 100. Okay, but I'll give them 100. Okay, I'll give them 500 if they quit crying. The fact is you can't measure 10 billion. Even though Congress does not seem to understand, there's a difference between 100 and 10 billion. Right? A big difference. So, I just don't believe people when they say you can measure a star distance, 10 billion light years away. They have other methods of trying to measure that distance, like redshift is the primary one, which we'll get into in a minute. But you just don't know those distances. Somebody says, that star is 10 billion light years away. Yeah, right. How'd you measure that? Was it a Stanley, a Lufkin, or a Craftsman tape measure? And who held the other end? That's what I want to know, right? Let me meet this guy. And who made that tape measure anyway? You just can't do that. So, you cannot measure distances beyond 100 light years. Now, people get upset with this and say, yes, you can. I don't believe you. Okay, if you think you can, I don't believe you. You'd have to prove it to me. I taught trigonometry. Explain it to me carefully. And I've had people give me snow jobs. When I taught school for 15 years, when you ask kids a question and they haven't done their homework and they don't know what they're talking about, they probably will give a huge, long answer to the question. It's called the snow job, right? How many know what I'm talking about? You did that yourself. Eric, you did that, I'm sure, yeah. So when a kid writes a 20-page answer to an essay question, you can rest assured he doesn't have a clue what he's talking about. He's trying to snow you, right? And a lot of these evolutionists will just flat try to snow you with their long answer. And you just got to watch for that. You just can't measure. Oh, yeah, I've done that in the debates. I say, you remind me of one of my students, Used to talk, which just to hide the fact they didn't have a clue what they're talking about. Secondly, no one knows what light is. And we don't know that it's always traveled the same speed. I mean, right now, something is hitting me and bouncing off of me, going into the camera and going out to you so your eye can pick up a vibration and translate it into a picture. What is it? And why does this show up one color and this show up a different color? You know, what is light anyway? Give me a jar of it, paint it red, and weigh it for me. We don't know what it is. We know what it does, and we use it, obviously, but we don't know what it is, the basic fundamental thing. The idea behind a black hole is that light can be attracted by gravity. If light can be attracted by gravity, then the speed of light cannot be a constant. Right? The theory behind a black hole is very simple. In order to escape from the Earth, to take off from Earth, you have to get going about 18 or 20,000 miles an hour, or you're going to fall back. If you go less than 18 or 20,000 miles an hour, 25,000 miles an hour, you're going to go, you might go up real high, but you're going to come back down. You can't escape Earth's gravity without going that speed. Suppose Earth had stronger gravity. You've got to go faster to get away, right? The Moon has much less gravity, so they had a lower escape velocity. If the Moon were the same size as the Earth, and we sent a rocket up there and wanted them to come back, they'd have to bring as much fuel with them to get off there as they did to get off here. Can't do that. So the ideas of putting colonies on Mars and colonies on Venus, I think, are highly unlikely because of this problem. They're much more dense than the Moon and have a much higher escape velocity. Jupiter, I forget the numbers now, like 318, rings a bell, times greater gravity on Jupiter. So if you landed on the Moon, you would weigh 1/6 as much. If you landed on Jupiter, you would weigh 300 times more than you weigh right now.
Could our bodies handle that?
No. Most of your bones, like your knees, can handle, I think it's like 17 times your body weight. So when you jump off of a step ladder and land, the bounce is,
About 5 or 6 times more.
yeah, you get up to about 17 times more and something's going to break. If you throw a cat off a 10-story building, he will land on his feet, but he'll walk like a duck for a long time afterwards. They just can't, the bones can only handle a certain amount of pressure. So if you got off the, even on the way into Jupiter, you couldn't have a soft landing for one thing, because it'd be sucking you in so hard, you'd splat in Jupiter. And then if you could land and get out of your spacecraft, you'd lay there and couldn't even lift your hand to scratch your nose. I mean, your hand would weigh 300 times more than it weighs right now. Suppose you had so much mass in one place that the escape velocity was the speed of light. Then light can't escape. To get off the Earth, you have to go 7 miles per second.
Do they get going around the Earth?
Slingshot them out. They use the slingshot effect to get to the Moon when they were going to go out to the outer planets. They would use the gravity of one planet to suck them in, and just try to miss it, and slingshot out, snap the whip kind of thing. Use that planet's gravity because you don't want to bring all that fuel for that whole journey. And it whips them on out. They got to do a lot of calculating before they go.
Miss it. Oh.
Oops, splat. I'll get another rocket ready, fellas. So yeah, is that a 3 or a 4? So the theory behind black holes is that if you get enough mass in one spot, light can't escape. Problem is then you can't see it.
Yeah.
So how do you know there's a black hole there? Oh, because it's dark. Oh, I see. That proves it. Duh, that doesn't prove a thing, okay? There might be black holes. I don't know. Nobody knows. It's a theory, a very reasonable theory. They could exist, but it is...
It's suck all matter in eventually?
Within a certain distance. It'd be like a vacuum cleaner. It's much stronger as you get close to the hole, but further away you have less suction.
It wouldn't have any effect.
Right. So the speed of light may or may not be a constant. Let's take a little break. After the break, we'll finish talking about the speed of light and starlight and get into Cepheid variables and redshift right after the break. All right, so black holes are theoretical, probably real, don't know, nobody knows. How could you prove one existed? I think there's light getting sucked in over there. Okay, maybe so. Maybe there's a cloud coming across your little telescope, Flock of birds, maybe. Like one guy had said he saw planets around a star. See, nobody's ever proven the existence of planets around a star, another star besides the sun. Okay, and every night he took thousands of pictures, and he would see the star appeared to move back and forth a little bit. And he said, "Oh, see, that's the planet going around, and it's causing the star to be, the gravity's pulling the star off course." Found out he had a wobble in his telescope base. Oops. There might be planets around other stars. I don't know. It doesn't matter to me. Okay, but nobody's ever proven they exist, as far as I'm concerned. Okay, in February of 1999, Houston Chronicle ran an article, page 10A, about a Danish physicist named Dr. Howe, working at Harvard, was able to slow light down by cooling it. They cooled it to 50 billionths of a degree above absolute zero.
Can I really measure that exactly?
I don't know. Pretty chilly. Don't lick it.
Isn't that temperature out in the universe, out in space?
Out in space is real close to that. It's about 3 degrees above that is what they think, negative 456. This is Fahrenheit. If you do it in Kelvin, it'd be 0. If you do it in centigrade, it's negative 273. But they slowed light down. When they got it that cold, light slowed down to 38 miles an hour. Then, in February, a couple of months later, February 2000, a year later, they slowed it down to 1 mile an hour. Then, in January of 2001, they stopped it. NewYorkTimes.com had an article, researchers say they have slowed light down to a dead stop.
What's it look like when it's stopped?
I don't know. They stored it and then released it as if it were an ordinary material particle. The achievement is a landmark feat that by reining in nature's swiftest and most ethereal form of energy for the first time could help realize what are now theoretical concepts for vastly increasing the speed of computers. Right now, the speed of computers, of course, is dependent on the speed of light. If the electricity can only go through there at 186,000 miles a second, what if it went through instantly? Gigahertz would be a snail, right? Another thing to consider, people say, boy, if I could travel at the speed of light, I'd go visit all the stars. Yeah, right, you'd be an old man by the time you got to the first one, right? What if you could travel at the speed of thought? All you have to do is think about being there. Of course, for some people, that'd be even slower. Right? So I had some students, they'd die if they did that. See, when we pray to God, how long does it take our prayers to get to heaven? Apparently faster than the speed of light. And when God answers our prayers, or when angels go back and forth, or in the book of Daniel, when the angel was coming down to answer Daniel's prayer, he said, as soon as you started praying, God sent me. Which leaves us, in our way of thinking, everything is three-dimensional. So heaven is out there someplace, okay? What if heaven is in a different dimension and it's right next to us, a half a second in the future?
It's always a half a second.
Or, a millionth of a second or something, What if there are other dimensions we have no concept of? Don't have a clue.
If I get a time machine, I can just go a thousandth of a second faster.
And be there, yeah. Could be. Anyway, these are things your brain, thinks on for a while and gives up because human brain won't wrap around that. 2 independent teams of physicists have achieved the result. One led by the same Dr. Howe of Harvard and Roland Institute for Science in Cambridge, Massachusetts. The other by Dr. Ronald Walsworth and a couple other guys whose names I cannot pronounce. Anyway, that Smithsonian and Harvard Smithsonian Center for Astrophysics in Cambridge. So these guys were slowing light down by cooling it and got down to actually stopping light altogether. In June of 2000, the Sunday Times in the United Kingdom announced, scientists claim they have broken the ultimate speed barrier, the speed of light. In research carried out in the United States, particle physicists have shown that light pulses can be accelerated up to 300 times their normal velocity. Dr. Li Jun Wan of University Research Institute in Princeton transmitted a pulse of light toward a chamber filled with specially treated cesium gas, and the light went through faster than light, 300 times faster. So the obvious question comes up, is the speed of light a constant? All of the arguments about the universe being billions of years old because the stars are so far away, all of those arguments are based on the assumption the speed of light is a constant. Daniel, you asked the question before the break, or just during the break. What was it about the starlight? Oh, are all the stars within a 6,000 light year radius, I guess? No. No question. There's so many stars. There's trillions of stars and trillions of galaxies. They're a long ways away. Much farther than 6,000 light years, for sure. But that doesn't mean the universe is more than 6,000 years old, if the speed of light has not been a constant through time. Matter of fact, Barry Setterfield has an article here in Atomic Constants, Light and Time magazine. During the last 300 years, he said, at least 164 separate measurements of the speed of light have been published. 16 different measurement techniques were used. The different ways to measure the speed of light. One way, if you know the distance to the moon, and the moon is moving across the sky in front of a star, you focus on that star carefully, and as soon as the moon goes past, how long does it take the light to get to you? Now you have a 243 million mile distance, and get a quick stopwatch and calculate the speed of light. There's 16 different ways that it's been measured. The way we did it in physics class when I was in school, you get mirrors, a bunch of mirrors arranged in a circle, like those disco balls, whatever they call them. Okay? You shine a laser all the way down the hall, bounce it off a mirror, bounce it back to another mirror, this disco ball, and bounce it back down the hall to a white piece of paper. And the length the light travels in is 3 trips down the hallway. Get your disco ball spinning on a record player, 33 RPM or 78 RPM or something. The light's going to bounce off that mirror, and once you get to a certain speed, you're going to see the light on the final leg on the piece of paper start to move. And now you can calculate how far did the light travel from the time it left the laser, bounced off the mirror, came back, bounced off this mirror, the mirror moved a little bit. Enough that even at the speed of light, you're able now to tell. If the little calculations, you can look up in a physics book how that's done, but it's not that complicated to measure the speed of light. Several of the methods are very, very simple. Setterfield says it's been measured for 164 separate times over 300 years. He said the speed of light has decreased so rapidly that experimental error cannot explain it. Here's the chart that Barry Setterfield got. Measurements back from 1860, clear up until the present. Now there's a margin of error. You see the lines on there? Different people measured the speed of light, and they would say the speed of light is X amount plus or minus so much. What he has graphed here is his the average of the light speeds that have been measured over the last 300 years, or since 1860, over the last 140 years. He said the speed of light decreased until about 1960. And the speed of light today, if you measure it, you always get the same, 186,000 miles per second. So why did it level out in 1960? Well, probably because that's when they invented the atomic clock. And I'll explain why. Everybody else is getting a greater number for the speed of light. Not much greater, a little bit, okay? You won't notice a difference when you shut the lights off to get to bed, okay? It's still real quick. But if the speed of light is decreasing until 1960, what made it level out? Let's assume that it has decreased. This article says, no physical law prevents anything from exceeding the speed of light. In 2 published experiments, the speed of light was apparently exceeded by as much as a factor of 100. This is clear back in 1988. They were getting measurements 100 times faster than the speed of light. So you can't say the speed of light has always been a constant. The atomic clock measures time based on the wavelength of a cesium atom. Let's see, the paragraph where it starts off, as a result, they defined the second of atomic time as the length of time required for 192,631,770 cycles of a cesium atom at 0 magnetic field. You're measuring the wavelength of a cesium atom and determining, okay, this is 1 second. Well, duh, if you're measuring time, if you're measuring light with light, you're not going to notice any decrease because your clock is decreasing at the same rate, right? So you have a rubber ruler.
If our clock is decreasing, does that mean time itself to us is decreasing? Or just, is it so insignificant we're not going to notice it in our lifetime?
We won't notice it in our lifetime or in a bunch of people's lifetimes. The article that Walt Brown has in his book is really good about atomic clocks. He said atomic clocks are very precise, but that does not mean they're accurate. He goes to great detail the difference between precision and accuracy. Read that when you get time. Dr. Troitsky said the speed of light was 10 billion times faster at time 0. Now, what does he mean by that? Well, according to the Big Bang theory, the Big Bang took place, everything took off faster than the speed of light. Otherwise, it wouldn't be here yet. So things were going faster than the speed of light initially. They have to believe that in order to get the universe to put together. See, and Hugh Ross has swallowed all of this and doesn't see the problem. Everything is based on the assumption that the speed of light has always been the same. Dr. Joao Magueggio, whoever he is, said, a shocking possibility is that the speed of light might change in time during the life of the universe. So I don't think we could prove the speed of light has always been the same. We certainly cannot measure the great distances to the stars. They probably are billions of light years away, but we don't know that. We can't measure it. Okay. And thirdly, the creation was finished. It was mature. When God made it and he was done, they could already see the stars. Even if they're billions of light years away, they could already see them. I often ask people, how old was Adam when God made him? He was 0. Did he look 0? No. He looked 48, prime of life. And so, if you walked into the Garden of Eden, the day after God made it, you'd see all these beautiful trees, all the fruit on them. Wow, how old are these trees? 0. Did they have rings? Yes. I don't know. Rings add strength to the tree called the laminate effect. You have hard ring, soft ring, hard ring, soft ring. Otherwise, the tree, all hard rings, it's real brittle, it breaks. All soft rings, it, like Jell-O, can't stand up. So the combination of the two gives you both strength and flexibility, which is why God sometimes puts us through hard times and good times and hard times and good times, and that adds those layers to your life, and you get both strength and flexibility. So God did not make 2 babies and put them in the Garden of Eden and hand them a package of seeds and say, here, plant these quick, you're going to need supper. Which came first, the chicken or the egg? The chicken. Which came first, the tree or the plant? Or the tree or the seed? The tree, okay? God made a mature creation. So, things to consider. Last 2. the creation was finished when God made it. That would include starlight being already showing on the earth. And a light year is a distance, it is not a time. Many people have a hard time grasping that concept. Since the speed of light is not proven to be consistent, why would star distance have anything to do with the age of the universe? Just because a star is 10 billion light years away, so does that prove the universe is 10 billion years old? No. Probably is 10 billion light years away. Okay. Another way they measure star distance is by using what's called the red shift, or measuring with a Cepheid variable. And we'll get into all that here. When light goes through a prism, it breaks it up into the colors: red, orange, yellow, green, blue, violet. Roy G. Biv, you learned that in school, right? How to memorize the colors. If starlight is traveling a great distance, or if the star is moving away from us, you should have what's called a red shift. Here's basically how it works. If a train is moving toward you, it compresses the sound waves and you hear a higher pitch. As it goes past you, the sound waves are stretched out or refracted, and you get a lower pitch. So the train will go as it goes by. That's called the Doppler effect, named after some guy named Doppler who discovered this. You can get the same thing with a whistle on a string, swing it over your head. A person out in the audience will hear, as it comes toward them, a higher pitch and a lower pitch as it goes on this side. It'll be woo, woo, woo. That's how sirens will work. They use that Doppler effect on a siren. As it spins around, they get a different sound. A change in pitch. And if you want to really get fancy, you could probably get musical notes. The pitch would be just right by spinning it at a certain speed. Or you could play, you know, B flat and C sharp or something if you want. So the train is using sound waves, and we know the Doppler effect works with that. The assumption is maybe the Doppler effect works with light. So if a star is coming toward us, it'll compress the light waves. If it's going away from us, it'll stretch them out, causing a red shift. So they say if a star is moving away, the light should be shifted toward the red end of the spectrum. Sounds good, possibly true. Nobody knows for sure what's causing the red shift. Jeffrey Burbridge and Adelaide Hewitt said in an article, A Catalog of Quasars Near and Far, Sky and Telescope magazine, 94, they said there was an early sign that redshifts reliably indicate the distance. Keep that in mind. They thought, wow, look how far that's redshifted. That proves it's X number zillion miles away. The distances of galaxies. For QSOs, abbreviated quasars, quasi-stellar object called a quasar. However, the diagram shows a wide scatter in apparent brightness at every redshift. In fact, there is little correlation of brightness to redshift at all. Either quasars come in an extremely wide range of intrinsic luminosities, that means their brightness. Maybe quasars are a lot different brightness. Maybe one quasar is real bright, one's real dim, as most people believe, or their redshifts do not indicate distance. Here's a guy admitting we don't know that redshift indicates the distance to the stars. Maybe it does. Well, maybe it doesn't. They go on to say, thus, for us, the only conclusion that can be drawn is that at least some quasars are relatively nearby, and that a large fraction of their redshift is due to something other than the expansion of the universe. When the redshift was discovered, they look at stars and see the red is shifted over. They say, wow, that star is moving away. Maybe so. We don't know. See one over here. Whew, that's moving away. Wow. If everywhere you look, the stars are moving away, you come to the conclusion, well, that means they must have all been together. And there was a big bang. Because after all, they're all moving away. Well, don't you see what an assumption you have here? First, you're assuming the redshift means they're moving away, which we don't know. Are there other things that might cause this? I think there is. And we'll get to that in a second. In Science News 95, September 9th, they said, another set of observations indicates that the universe appears to be 4.8 to 10.6 billion years old. Now, wait a minute. I've got textbooks that say it's 20 billion years old. How do you revise it down to 8.4? I said 4.6. 8.4 billion. Well, to calculate the age of the universe, they've got an equation which includes what's called the Hubble constant, named after the guy named Hubble, that the telescope is also named after, the Hubble Space Telescope. The new work relied on the Hubble Space Telescope to obtain distance to faraway galaxies. A team led by Neil Tanver of University of Cambridge in England used a two-step method to estimate the Hubble constant. First, they observed a type of standard candle known as Cepheid variables to find the distance to the spiral galaxy M96. You have to be careful about drawing conclusions because of the Hubble constant. Measurements have huge systematic errors. Suppose I was going to calculate the population of the Earth in 100 years. And I say, well, the population grows by 8% every year, and I do that times for 100 years. Isn't my answer I come up with dependent on the numbers I put into that equation? That 8% determines everything about the outcome of the answer, doesn't it? Suppose I found out, oops, it's really only 2%. Greatly modifies your number. What if, oops, it's only 0.5%? The Hubble constant is one of the multipliers in the equation.
It is not really a constant.
It's not a constant. All you got to do is change that number a little bit, and all of a sudden the universe is no longer 20 billion years old. Now it's only 8.4. Hubble constant is a far cry from a constant. Even the nearest Cepheids are so remote, it's difficult to determine their absolute distance with any great accuracy, this guy says. All large distances in astronomical literature are subject to an error of perhaps 10% from this cause alone. 10% error is a pretty big amount. We know that faintness, now here's what they do. They look at a star and say, wow, that one's bright. Must be close. That one's dim. Must be far away. Error in logic right there. It's called faintness. How bright is the star? The faintness arises from two causes: distance and absorbing matter. There's a cloud in the way. Something's absorbing the light. I could shine a bright spotlight through something that would make it look very dim to you, and it'd only be 5 feet away. And you would say, wow, it's pretty dim. Must be millions of miles away. No, there's something absorbing the light in between. He said it's not generally possible to apportion the accuracy accurately between the two. The Bible says God stretched out the heavens. He stretches them out. Several different references in the Bible talk about God stretching out the heavens. Maybe that is what is causing the red shift, the stretching of the heavens. So let's close here. What's causing the red shift? Nobody knows. A couple of theories. One is the heavens are stretched out. If God created everything from here and stretched it out, the star is moving, and we would see a red shift in the light. Not because it's billions of years old, but because God stretched it out. Okay? Could be the light's getting tired. Everything else gets tired when it travels a long ways. I do. Right? Maybe the light is getting tired while you get a red shift. Maybe it's just the effects of traveling great distance. Maybe it's the Doppler effect. Maybe the star is moving away. It's a very reasonable possibility, but not the only possibility. Maybe light is being slowed down or speeded up by gravity. If black holes are real, suppose a star is sending its light to the Earth and it's going near a black hole, but not going to hit it. It'll be slingshotted right by. It'll be speeded up on the way in, then sent onto the Earth. So you can't say, we know the universe is billions of years old because the star is a billion light years away. You just can't do that. You have too many assumptions built into your equation. When you get into the stars, you know, do they tell a story? Is there a gospel message in the stars? Hank Hanegraaff has blasted me 3 times on his radio program without ever giving me a chance to respond. The Bible Answer Man. He says, Hovind believes in the gospel in the stars. I don't know if I believe in it or not. Okay, it's just an interesting theory, and I think it's worth study. D. James Kennedy has a great book out called The Real Meaning of the Zodiac. He says there are 88 constellations, and several of them mentioned in the Bible. In Job 38 talks about Pleiades and Orion. Job 38:32 talks about Mazzaroth and Arcturus. These are constellations in the sky. Now, when I look up at the sky, I see a bunch of stars. I don't see a bear. I don't see a lion. I don't see Draco the dragon. It looks to me like a bunch of stars. Anybody else see the same thing when you look up there? Okay. But apparently, in the old days, they sat around watching the sheep and didn't have much else to do and said, you know, that looks kind of like a bear up there, you know. There's his tail. You see his, oh, yeah, I see his tail. Okay, see, that's a bear. Who made this up? Nobody knows. Several theories are. One is it's purely heathen and nothing to it. Another theory is that God told Adam the whole gospel story and put it in the stars. Virgo the virgin is going to bring forth a son. Later we have Libra, the balances. He's going to be the judge. You know, the zodiac symbols. Then Gemini, twins, Cancer. You go through the whole zodiac thing. Now, of course, today, that's all perverted into the horoscope, which is a bunch of baloney. One time, I think it was the New York Times or somebody forgot to print the horoscope in their newspaper, major newspaper in New York. Every morning, the horoscope's in there, you know, tells you what kind of good day you're going to have, like a Chinese fortune cookie. All right? 1 million people refused to go to work because they couldn't read the horoscope to find out if they're going to have a good day or not. We got a word for that down here in Florida. It's called stupid. Okay? Those New Yorkers that didn't go to work need some help. The stars do not have any influence over what's going on. Except if you lay out too late watching them, you won't be able to get up in the morning and go to work because you didn't get enough sleep. So these are these constellations. The 12 zodiac symbols has other minor constellations associated with it. There's 88 total. And D. James Kennedy's book and many other books have been written claiming that this is actually telling us a story. The gospel story. That could be, I don't know. I think if you want to study it, great, enjoy yourself. But Hank, don't accuse me of teaching that dogmatically because I don't. Okay, I don't know the truth on that, and I'd like to get on and defend myself on your program sometime if you want to be fair about it. Virgo the Virgin is one of the star clusters. Leo the Lion is another one. Some people have said the Sphinx might be put there, might have been put there to tell us how to read the zodiac symbols. You start with Virgo the Virgin, the face of a woman, and it's got the body of a lion on the Sphinx by the Great Pyramid. Interesting study. Okay, next week, take up some more questions, then we'll hopefully get into, be able to finish all the questions and answers over the next few lessons so we can finish after 104, and we'll get into carbon dating. How does that work? Try to get into that next week. Thank you so much.